All right, in this video, we're going to talk about suggested homework problems from 3.2. Let's go ahead and get started. First question is to, in your own words, describe the mean value theorem. So let f be continuous on the closed interval a to b and differentiable on the open interval a to b. The mean value theorem guarantees at least one value C that's in A to B such that f prime of C is equal to the average rate of change, f of B minus f of A over B minus A. So the another way to say this is the instantaneous rate of change is equal to the average rate of change or another way to say that is the slope of the tangent line at C is equal to the slope of the secant line from x equals A to x equals B, or to say the slope of the secant line on closed interval A to B, like that. So you have a secant line passes through 2 points on the graph and as an average rate of change. The tangent line touches at 1 point C and is an instantaneous rate of change. So you can think about that all those different ways. Let's jump now to number 11. Key thing here is to remember that you must establish these two conditions. Condition 1, that it's continuous, and condition 2, that it's differentiable before you can use the mean value theorem. If you do not do that, first, you're going to run into problems because we're going to have times where the mean value theorem does not apply, and you're going to get nonsense answers or get, wrong answers if you don't test those conditions first. So f of x is equal to negative x squared plus 3x on the interval 0 to 3. So mean value theorem is going to apply because we have a polynomial that is continuous and differentiable everywhere. Okay, so both conditions are met. Let's go ahead and find f prime of x is negative 2x plus 3. We'll substitute the letter C here to make it consistent with the theorem. Let's find slope of the secant line is equal to f of 3 minus f of 0 over 3 minus 0 is f of 3 is negative 3 squared plus 3 times 3 minus a negative 0 squared minus 3 times 0, that's 0 over 3. So this is going to be slope of the secant line, negative 9 plus 9 plus 0 minus 0 over 3. This is 0. So we have Rolle's theorem applies. I didn't tell you Rolle's theorem has an extra condition here that says f of a equals f of b. So that's really what I just found. Let me just do it that way, since we're specifically on Rolle's theorem. F of 0 is 0. F of 3 is negative 9 plus 9 is 0. So that's condition 3 that's met. So Rolle's theorem applies. All right, so there is a negative 2c plus 3 is going to be equal to the average rate of change is 0. Negative 2c is negative 3, and c is equal to 3 halves. 3 halves is within the interval of 0 to 3, so we're good. Now at number 15, again, this is Rolle's theorem, so we need all 3 conditions to be met, including that f of a equals f of b, so f of x is equal to x to the 2/3 minus 1 on negative 8 to 8. Rolle's theorem does not apply because f of x is not differentiable at x equals 0, which is in the interval of negative 8 to 8. So we just stop and say it does not apply. That was 15. 21. F of x is equal to cosine of pi x on the interval of 0 to 2. So f of 0 is cosine of 0 is 1. F of 2 is cosine of 2 pi, which is also 1. And mean value theorem applies because f of x is continuous and differentiable everywhere. Graph of cosine is a smooth curve. So that means Rolle's theorem applies. Because we have the conditions for the mean value theorem plus the extra condition, the f of a equals f of b. So f prime of x is equal to a negative sine of pi x times pi. F prime of c is negative pi sine of pi times c, and that's going to be equal to 0. So divide by negative pi, sine of pi times c is equal to 0. Pi times c is going to be equal to zeros of sine are at 0, pi, 2 pi, so on. So c is going to be 0, 1, 2, 3, so on. Well, I want a c that's in the middle of the interval, so I don't want 0, I don't want 2, I don't want anything bigger, I don't want anything smaller. The only one that I want is 1 for my value there. Let's look now at number 29. It's a vertical motion problem. So f of t is equal to negative 16t squared plus 48t plus 6. That's a polynomial, so the mean value theorem applies. All we have left to do to use Rolle's theorem is to check that on the interval 1, 2 that we're interested in, that f of 1 equals f of 2. So f of 1 is negative 16 plus 48 plus 6 is 32 plus 6 is 38. And f of 2 is negative 16 times 4 plus 96 plus 6 is a negative 64 plus 96 plus 6 is 32 plus 6 is 38. And so, yep, they have the same y value, so the average rate of change is 0. So Rolle's theorem applies. So for part B, let's find the C value that's between 1 and 2 that's guaranteed by Rolle's theorem. So f prime of t is equal to a negative 32t plus 48. F prime of c is negative 32c plus 48. We're going to set that equal to 0 because that's the average rate of change. 32c, negative 32c is equal to a negative 48. C is 48 over 32. Both of those are divisible by 16. 48 times 3, or 16 times 3 is 48, and 16 times 2 is 32. So you can call it 3/2 of a second, or 1 5/10 seconds, or 1.5 seconds. I don't care, whichever format is correct for your instructions that you're given. I like improper fractions usually the best, so I'll leave it as 3/2. Let's look now at number 37. And it's just a mean value theorem question this time, not Rolle's theorem. A fun fact, Rolle's theorem came first, even though it seems like a specific case of the mean value theorem. We were more interested in these places where the slope was 0 than anything else. And you can also use this same idea back in pre-calculus to prove the existence of a x-intercept. So you can use these ideas to say that the function has to take on a particular value sometime between two values that are different, any y value in between. But if you get it between a negative y value and a positive y value, and there's a sign change, there must be at least 1 0 somewhere between those x values in that interval. And that's kind of what your calculator does to find x-intercepts, and it just does it very quickly. So we've got the graph to go with this one. We're given the points P of -1, 4 and Q of 2, 1. And we want to find the slope of the secant line that goes through them is going to be 1 minus 4 over 2 minus a -1 is a -3 over 3 is a -1. And then we want to find the equation of that tangent line that goes through them. And we're just going to write the form of this that's not solve for y. We're going to get rid of as many fractions as we can here. So y minus, I'm going to choose this point over here, y1 equals this m times that x minus that x1, and y minus 1 equals negative x plus 2. And then I'm going to bring everything over to the left-hand side. X plus y minus 3 equals 0. That was all part A. Part B asks me to use the mean value theorem, which I know the mean value theorem applies since this is a polynomial. It's continuous and differential everywhere, so it's definitely continuous and differential on this closed interval from -1 to 2. And we found our f of 2 and our f of -1 here. So we have f prime of x is a -2x. So f prime of c is a -2c. I want that -2c to be set equal to my average rate of change of -1, so c is equal to 1/2. And now I want to find the equation of the tangent line at c. So f of c is f of 1/2 is equal to -1/2 quantity squared plus 5 is a -1/4 plus 20 quarters is 19 quarters. So c y minus 19 quarters is equal to the slope of -1. It's the same for the secant and tangent line. X minus 1/2. And then we have y minus 19 quarters is equal to a -x plus 1/2. I'd like to clear the fractions by multiplying everything by 4. So 4y minus 19 equals -4x plus 2. And then bring the x's over, subtract the 2, get it all equal to 0. And I have the equation of my tangent line, just not in the form where it's solved for y. So let's probably see. All right. 39 is f of x is equal to 6x cubed on the interval from 1 to 2. Again, it's a polynomial, so the mean value theorem definitely applies. F prime of x is equal to 18x squared. So f prime of c is 18c squared. Let's find f of 1 is 6 times 1 cubed is 6 times 1 is 6. And f of 2 is 6 times 2 cubed is 6 times 8 is 48. So we have slope of the secant line is 48 minus 6 over 2 minus 1. That's the slope of the secant line is 42 over 1 is 42. I want to set this equal to my average rate of change of 42. C squared is 42 over 18. So this is 7 over 3. C is, I have no problem with you leaving that as root 7 over 3 inside because 7 and 3 have no common factors. There's no reason that I see to rationalize that. I would leave it that way, but your book is going to make you rationalize this if you check your answers. So they're going to call that root 21 over 3, like that. I'm going to use this form when I go back and verify that root 7 over 3, like that, for my derivative is 18 times root 7/3 squared, because that square and that square root will get rid of each other. 18 times 7/3, 3 goes into 18 6 times. 6 times 7 is 42, which is my average rate of change here. And that's what I wanted, my instantaneous rate of change at C to be equal to my average rate of change over the interval. Let's look at number 41. 41 says f of x is equal to x cubed plus 2x plus 4 on the interval -1 to 0. So f prime of x is 3x squared plus 2. Mean value theorem definitely applies here because it's a polynomial. F of -1 is -1 minus 2 plus 4. -3 plus 4 is 1. F of 0 is 0 plus 0 plus 4 is 4. So slope of my secant line is 4 minus 1 over 0 minus a -1, 0 plus 1. 3 over 1 is 3. So f prime of c is 3c squared plus 2, and I need to set that equal to 3. So 3c squared is equal to 1, c squared is 1/3. Again, c is equal to, and now it's going to be a negative root 1/3 because we are between -1 and 0. I chose the positive option last time because of my a to b. I'm choosing the negative option for the square root this time because of my interval a to b. I have to be, my c value needs to be between my a and my b. So choose the correct sign when you do that. Again, your book is going to say that you should rationalize this and do what is required of you. I'm going to use this when I verify because it makes it easier to square the square root. So 3 negative root 1/3 squared plus 2 is 3 times 1/3 plus 2. 1 plus 2 is 3, which is my average rate of change there. So that's correct. So now at 48. F of x is equal to cosine of x plus tangent x on the interval from 0 to pi. Mean value theorem does not apply. Because f of x is not differentiable. Or continuous at x equals pi over 2. There's a vertical asymptote there for tangent. Right? So let's go on to number 53. 53 says, and you're going to want to have your calculators ready. I've already done these calculations for you, but you're going to want to verify them probably. So S of t is -4.9 t squared plus 300 foot tall building. We're dealing with gravity that's measured in meters per second squared. So we have velocities that are going to be measured in meters per second. So find the average velocity during the first 3 seconds. So we're looking at 0 to 3 for our interval. S of 0 is going to be 300. S of 3 is -4.9 times 3 squared plus 300 is 9 times negative 4.9 is negative 44.1 plus 300 is 299, 9, 5, 5, 2, 55.9. So we have the average on the interval is going to be final minus initial over final minus initial. The average is going to be a negative 44.1 over 3, and that's meters per second. So the average is equal to, when I divide that out, that's a negative 14.7 meters per second. That's for part A. Part B says use the mean value theorem, which applies here because this is a polynomial here. To prove that there's some time where the instantaneous rate of change is exactly negative 14.7. So S prime of t is equal to a negative 9.8 t. S prime of c is negative 9.8 c. I'm going to set that equal to negative 14.7. C is 14.7 divided by 9.8. Those negatives will get rid of each other. You stick that into your calculator, you're going to get 3/2 of a second, or 1.5 seconds, or 1.5 seconds, however you're asked to format your answer. All right, let's look at 59 to wrap this up. A plane begins takeoff at 2 p.m. That's not important. On a 2,500 mile flight, the average is equal to delta S over delta T. So 2,500 miles, and it takes 5.5 hours for that to happen. Divide that out, and V average is going to be about, we're going to have to round this, 454.5 miles per hour. So then the question is, explain why there are at least 2 times during the flight when the speed of the plane is 400 miles per hour. So if there's this point of maximum speed somewhere, or where the mean value theorem, let's just say it this way, the mean value theorem guarantees time equals c, such that S prime of c is equal to 454.5 miles per hour, guarantees at least one t equals c such that S prime of c is equal to 454 miles per hour. Because 400 is below 4, because we must accelerate to at least 454.5 miles per hour from 0 miles per hour, we must pass through 400 miles per hour on the way to 454.5 miles per hour. And because we must reach 0 miles per hour to land safely, we must again pass through 400 miles per hour as we decelerate from 454.5 miles per hour as we are landing. So there's two times. There's once as we're going towards that average speed, and once as we're coming back from that average speed, decelerating in order to land. So probably once on takeoff and once on landing but I'm not absolutely sure that they happen exactly at takeoff and landing. But that's the idea, is that you're going to have to hit every speed between 0 and 454.5, and then every speed between 454.5 and 0. So you're going to hit 400 at least twice. All right, that's it for this video. We'll come back next time and talk about section 3.3. See you for the next video.